Find the inverse Laplace transforms of the given functions. In part A, our function is 1 over s square minus 4s plus 5. Okay, and look at the table here. And we know that when we have 1 over s minus some number, and that will be just the coming from EAT. So if the bottom factors, then we can use the partial fraction decomposition to write this as a sum of two simpler fractions and use this rule. 5 is 5 times 1, 5. So plus. No, this does not factor properly. Okay. Look at B. S square minus s minus 6. 6. 3 times 2, 6. And 3 and 2 make negative 1. So this factors. So part B, this complex fraction can be written as a sum of two simpler fractions, like something over s minus a, and we can always go for exponential function. But in this case now, we need to look at the table, and that is closest to this function. Look at the function in the right hand side. Obviously we have s square and s more than that, so not gonna be no. Maybe look at here, this number, right? It's this. We have a number over s minus a square plus b square. So basically completing the square with s and making sum of two squares. So bottom s square minus 4s plus 5 we can write in this form, because s square minus 4s, if we add 4, then this is just s minus 2 square. So let's rewrite this function as 1 over s square minus 4s plus half of negative 4, which is negative 2. Negative 2 square is 4. So add 4, and to balance this we have to subtract 4 plus 5. And this is in fact 1 over, for the first three terms, that's a complete square now, and that's s minus 2 quantity square. 5 minus 4 is 1. Okay, then the bottom is now exactly in the form we wanted. Look at the right hand side. So B, I mean, we could have any number, we can always pull to the front. S minus a square plus b square. 1 is 1 square. Then the function is EAT, e raised to 2t, sine bt, sine 1t, or just t. Okay, final for the number A, but let's do part B now. In this case, we have now two options. Okay, we can complete the square on the bottom like this, and then we can make like the second one here. But the easier method would be just write this as a sum of two simpler fractions. So I'm gonna let 2s over s square minus s minus 6 as a sum of two simpler fractions, a over plus b over. And if we factor s square minus s minus 6, we get s minus 3, s plus 2. So s minus 3, s plus 2. Then if we combine these two fractions, the bottoms cancel. That implies 2s equals a times s plus 2 plus b times s minus 3. And this is assumed to be true for all s. Now we want to take specific s so that we can find a and b. Take s equals 3, then this 6, 3 minus 3 is 0, this b part is 0, 3 plus 2 5, 5a. That means a equals 6 over 5. And in this equation, take s equals negative 2. Negative 2 plus 2, that's 0, this is 0. 2 times negative 2 is negative 4, equals gone. Negative 2 minus 3, negative 5b. or divided by negative 5, so b equals 4 over 5. So thus, okay, we can rewrite the given function complex fraction as a sum of two simpler fractions, a over s minus 3, and a is 6 over 5, so 6 over 5 times 1 over s minus 3, 6 over 5 over s minus 3, but I'm rewriting this in the front, plus b over s plus 2, so b is 4/5, so we can pull outside 4/5 1 over s plus 2. Now this is in the exact form of 1 over s minus a, and whose inverse Laplace is EAT. Okay, then that, so our function, our answer is now 6 over 5, and inverse Laplace of this is e raised to 3t, plus 4 over 5, and inverse Laplace of 1 over s plus 2 is e raised to negative 2t. Okay, s minus negative 2, so negative 2t final.